All right, we're going to talk about quadratic formula. You guys familiar with that? You guys remember what that is or have heard of it? Probably since middle school, maybe. All right. Quadratic formula is just another way to approach quadratic functions or equations. Okay? And so if you have an equation of the form ax squared plus bx plus c equals 0, so standard form, another way that you can solve this instead of looking to factor it or to complete the square and rewrite it is you can use quadratic formula. So I'm going to talk through the steps that I'm going to go through here in just a second are going to show you how the quadratic formula was derived, so how it even came to be. Okay, so you don't have to mimic this, and if you want, you can wait. I'll print these notes out in PDF form. If it makes more sense for you to wait on that, or you can follow along with me. It's up to you. Right? All right, so if we went through all the steps to complete the square, the things that we talked about in the last section, with this just generic form, or we're not even going to give values to a, b, and c. We're just going to leave them as variables. Let's see what would happen. Okay. So the first step in completing the square was to isolate the constant. We'll move that over. And at the same time, we can factor out an a. Okay. So we factor out the leading coefficient. So if we take out the leading coefficient, taking out an a from a bx leaves b over a. Again, we divided an a out, so if it wasn't there, it winds up in the denominator. We'll leave a space here to complete the square. We're going to subtract a c from both sides. Okay. Now, the next part, before we actually go in here to complete the square, let's go ahead and get rid of this leading coefficient of a. So we're going to divide both sides by a to get rid of that. Right, now what we can do is we can complete the square. So when you complete the square, you take your b value. So the b value is the first degree term's coefficient, which is b over a now. And we're going to take 1/2 of that. So taking 1/2 of this is like multiplying it by 1 over 2. So you get b over 2a. And then we're going to square it and add it to both sides. Okay, so we're going to get b squared over 2 squared a squared. We're going to do the same thing over here. We're going to add b squared 2 squared a squared. Okay, so we just completed the square. After you complete the square, and the whole purpose for completing the square is it allows you to rewrite the left side as a binomial square. First term x, the second term is going to be, again, whatever half of that first degree term's coefficient was. So half of b over a was b over 2a. So that's our binomial square. And then on the right side, I'm just going to combine these into one common denominator. So the common denominator is going to be 4a squared. So in order to combine these fractions with an LCD of 4a squared, I needed to add a 4 to the denominator here, which means multiply top and bottom by 4. I needed to multiply by another a to get the squared in the denominator. So I get 4ac, so negative 4ac plus b squared in the numerator, and then 4a squared in the denominator. So all I did on the right side was I combined those using the rules to combine into a single fraction. Okay, the next step is to extract the square root. When you extract a square root, you have to take into consideration the positive and negative root. So we get a negative 4ac and a plus b squared. In the denominator, I can go ahead and I can apply that square root. So the square root of 4 simplifies to 2. Square root of a squared simplifies to an a. Okay, so my last step here is to isolate and solve for my x. So I'm going to subtract a b over 2a from both sides. Now when I rewrite this left side or this right side here, I'm just going to reorganize my terms. I'm going to put my b squared first and my minus 4ac second. And now these two fractions actually have the same denominator, so I can combine them into one single fraction. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And what is that actually? That is the quadratic formula, right? So quadratic formula is just completing the square. It's all the same thing. In fact, I mean, if you ever had to do something by hand, assuming that the numbers weren't extremely huge. Completing the square is always going to give you smaller, easy to work with numbers. In my opinion, it's an easier way to approach a problem. And quadratic formula is kind of a last resort. Now, if you had teachers that would let you use the quadratic formula because you were using calculators, and like, do you think I'm going to make you use quadratic formula with your calculators? No. What's a more efficient way to use your calculators since you paid $160 for them? Can you solve using what? Solve. Yeah, just use solve. I mean, if you have a calculator that can solve it, there's no reason to go through this process of applying quadratic formula. Just use the solve feature. Okay. Now, if you're doing a problem on like an ACT type of test or a test that doesn't allow you to bring your TID9s, then you might want to refresh and look over this and use the quadratic formula. All right, so here's the only thing though let me have you do an example really quickly. So again, if ax squared plus bx plus c equals 0, then the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is your generic quadratic formula. But like I said, if they give you a problem that asks you to solve, just use any method, be the most efficient way, or approach it the most efficient way that you can. Okay, so see if you can solve this equation really quickly for me, please. What'd you guys get? Okay, so false. What does false? Now remember, now in this chapter we started talking about what false does, JT.
3 plus I or 3 minus
Right.
I.
So false means there's no real solution. So what do you have to do to find the non-real solutions? Seesaw. Okay, right. So if you go through and let's say using your calculator, you go F2, solve, and you type your equation. X squared minus 6x is equal to negative 10. Solve for x. Hey, false. All false tells you is there's no real solutions. Okay? If it's still asking, depending on what the question asks, if the question asks identify the real solutions or rational solutions, you would write not possible or none. Okay? But if it asks what are the solutions, that includes any all complex numbers. So if you type a C in front, what does, again, the C represents complex solutions, meaning real and imaginary. So if you hit that, you now get your solutions in terms of I. So you have 3 minus I and 3 plus I. Okay? And so those would be your two solutions. And now, just so you've seen this done by hand, if you had to answer this question by using quadratic formula, what you would do is you would rewrite this in standard form. So we'd add 10 to both sides and set it equal to 0. And so write in your standard form. This allows you to find the values for A, B, and C. So here, and I'm going to actually write them. So A is 1, B is negative 6, and C is 10. And then you're just going to plug those values into this form. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So if we plug these in and solved, we would get negative 6 plus or minus the square root of negative 6 squared, which is 36, minus 4 times a times c all over 2 times a. Simplify what you have, we get 6 plus or minus 36 minus 40 over 2, which would simplify into a negative 4 here. The square root of negative 4, you can see right there that it's going to be an imaginary number. So we get 6 plus or minus, and this becomes 2i. right? The square root, if you look at the square root of 4, the square root of negative 1 comes out as the I, and that leaves a 4. Square root of 4 comes out as a 2. And so when you distribute, or when you divide this number with a numerator with 2 parts, 2 terms, and a denominator with 1, you have to distribute the denominator into each individual part. So 6 over 2 plus or minus 2I over 2, and that simplifies to your answer 3 plus or minus I.